11-2. All right, we're talking about special right triangles today. Special right triangles. There's two types of triangles we're going to work with today. They're considered special because they have specific rules related to them that allow you to determine side lengths without using the Pythagorean theorem. Okay? So, the first type of special right triangle is a 45, 45, 90. So here we go. In a 45, 45, 90 right triangle, the legs are congruent. And the length of the hypotenuse is the square root of 2 times the length of a leg. The length of a leg is the hypotenuse divided by square root of 2. Oops. So the way that this works is if you see a triangle, and it's a right triangle, and if one of these angles is 45 degrees, then what's the value of the other angle? Other one has to be 45, right? Because the two acute angles in a right triangle sum 90. So if you see a 90-degree angle and one angle is 45, you know the other angle is 45. So you need to immediately think of special right triangle. All right? So let's say that you're given this side and you need to find the other two sides. Here's how hard it is. The legs are congruent. So what's this left side? 6. And the hypotenuse is equal to 6 is equal to 6 times the square root of 2. That's your shortcut. So look, what's going on with this computer? Come on. What's going on here? So let's say we get this triangle and we get one leg. That's 9 times square root of 2. All right, since it's a 45, 45, 90, we know that both of the legs are congruent. So this leg on the right is 9 radical 2. All right, and this third side. Now, this isn't quite as simple as the last problem. So this third side, this x, we're going to say that x equals that's going to be 9 radical 2 times the square root of 2. Now, when you're dealing with radicals in this case, you're allowed to multiply numbers that are outside the radical by numbers that are outside the radical. Okay? And you're allowed to multiply numbers under the radical by other numbers that are under the radical. That's the rule. So do you see this second square root of 2 here? There's a 1 in front of that radical, but it's not written, it's just implied. So what you have here is 9 radical 2 times 1 radical 2. So that 9 times 1 is going to be equal to 9. And then when you multiply the numbers under the radical, you get the square root of 2 times the square root of 2, which is the square root of 4. Which is the square root of 4. Square root of 4 is a perfect square, isn't it? The square root of 4 is equal to 2, so we simplify it to a 2. So this becomes 9 times 2. So x in this case is equal to 18. Make sense? (45, 45, 90). Hypotenuse is square root of 2 longer than a leg. All right, so if we get a 4 right here and an x, x in this case is going to be equal to 4 times the square root of 2. It's that simple, you're done. Okay? If we get a leg that's equal to 7, times the square root of 2. Oh my goodness, this cursor's killing me. And we got to find the hypotenuse. Y'all go ahead and finish that one. I'm sorry, that should have been an X over there. So if we got to solve for X right here, our X is going to be equal to 7 radical 2 times the square root of 2. So that's equal to 7 times the square root of 4. And what's 7 times the square root of 4 equal to? 14. Good. So x is equal to 14. Everybody okay with that? All right, now let's do when you give you the hypotenuse. Now I gotta learn another technique here. All right, let's say that we got a 45, 45, 90, and we are given the hypotenuse, and it's equal to 12. And we need to find the legs. All right, so look, we said that a leg is equal to the hypotenuse divided by the square root of 2. So watch, x is equal to 12 divided by the square root of 2. Now, if you just need a decimal answer, then you can just type this in your calculator. 12 divided by 2 square root equals, and you get 8.49. All right? But now, if you need your answer to be in simplest radical form, when you're simplifying radicals, you cannot have a radical in the denominator. Okay? Can't have a radical in the denominator. So maybe write that down right here. Cannot have a radical in the denominator. Real important. So, when you have a value and you do have a radical in the denominator, the technique that you use is you multiply both the numerator and the denominator by whatever is in the denominator, okay? You multiply the numerator and the denominator by whatever the radical is in the denominator. And what it does is it eliminates the radical in the denominator. So what you end up with here is, look, in the numerator, you get 12 times square root of 2, which is 12 radical 2. And in the denominator, we just did this. What's the square root of 2 times the square root of 2? Square root of 4, which equals 2. So by multiplying the square root of 2 in the denominator by itself, you eliminate the radical, don't you? And now, just like you can multiply numbers that are outside the radical, you can also divide numbers that are outside the radical. So you can take this 12 and you can divide it by the 2 here, and you get 6 radical 2. So there's the length of the 2 legs of this right triangle. All right, if we get this, x, x, and now our hypotenuse is 5 radical 2. Well, our legs, x is going to be equal to the hypotenuse, which is 5 radical 2, divided by radical 2. And again, you can divide numbers outside the radical by numbers outside the radical. And you can do the same thing with numbers under the radical. So right here, you got the square root of 2 divided by the square root of 2. Doesn't anything divided by itself just cancel out? Okay. So what's x equal to? 5. Good. So there, x equals 5. Everybody all right with that? Any questions on working with the 45, 45, 90? Legs are the same. Hypotenuse is equal to a leg times the square root of 2. A leg is equal to the hypotenuse divided by the square root of 2. All right. So let's do this. 30, 60, 90. Right triangle. Thirty, 60, 90 right triangle rules. So let's take a look at a 30, 60, 90. We're going to make this the 30-degree angle. This is the 60-degree angle. Here's the deal on the 30, 60, 90. Do you see the leg across from the 30-degree angle? The leg across from the 30-degree angle, that's called the short leg. The leg across from the 60-degree angle, that's called the long leg. And the side across from the 90 is always called the hypotenuse. Now, all these three sides, or these three sides, have a special relationship in a 30, 60, 90 triangle. If the short leg is equal to x units long, the hypotenuse is equal to 2 times x. The hypotenuse is twice as long as a short leg in a 30, 60, 90. The long leg is equal to the short leg times the square root of 3. So this has been a little bit helpful in the past. All right. We're going to say hypotenuse is equal to short leg times 2. Make sense? All right. Long leg. What's the long leg equal to? Good. The short leg times the square root of 3. Now you got 2 ways to find the short leg. The short leg is either equal to the hypotenuse divided by 2, or the short leg can also be equal to the long leg divided by what? Radical 3, good. And you use those rules to work your way around a 30, 60, 90 without having to do the Pythagorean theorem or distance formula or any of that other stuff. All right, they're special right triangles, so they have these special rules. So let's apply some of these rules now. Find some leg lengths. All right, so let's make this our 30 and our 60. And let's say our long leg is 15. We need X and Y. Now, as you're starting to use these rules in the 30, 60, 90s especially, you see the 60, you go across from the 60, you see a 15, just maybe label it long leg. That makes this your short leg. You know that's your hypotenuse. I hope you don't, I don't know. You can label it if you want to. It's there. It's your H. So look, they gave you the long leg, right? And you need the short leg. So look what the short leg is equal to. The short leg is equal to the long leg divided by the square root of 3. Right? So X, your short leg, equals the long leg, 15, divided by the square root of 3. If you need the decimal version, you type it into your calculator, 15 divided by 3 square root. If you need it in simplest radical form, then you multiply the numerator and the denominator by the square root of 3. So in the numerator, you get 15 radical 3. In the denominator, what do you get? Square root of 3 times square root of 3. Square root of 9, which equals what? 3. Anytime you multiply a radical by itself, you get the same number without the radical. The square root of 4 times the square root of 4 equals 4. The square root of x times the square root of x equals x. All right, and then in this case, you can simplify this 15 over 3. 3 goes into 15 5 times, so this becomes 5 radical 3. So that's your short leg, agreed? X equals 5 radical 3. Now you need your hypotenuse. What do we say the hypotenuse is equal to? Hypotenuse equals short leg times 2. So our y equals the short leg, which is 5 radical 3, times 2. And 5 radical 3 times 2 is 10 radical 3. So there's our hypotenuse. 10 radical 3. How's your level of comprehension right now? Foggy because it's Monday, or rubbing the boogers out of your eyes? Stare at the wall, not say nothing? It was so much fun, you want to do it again? Oh, okay, great. I love special right triangles. Let's try one like this. And we're given the hypotenuse. Hypotenuse is 10. Short leg is X. Long leg is Y. All right. Here's our H. Here's our long leg. Here's our short leg. We're given the hypotenuse. All right. There's not a, there is, but there isn't. There's not a direct path from hypotenuse to long leg. It's 2 steps. So you might as well just go hypotenuse to short leg first. Okay? So what does a short leg equal to? Hypotenuse, what? Let's see. Short leg, we just wrote it down. Short leg equals hypotenuse divided by 2. There we go. So short leg equals 10 divided by 2, which equals 5. So our X equals 5. What does our long leg equal? 5 times the square root of 3. And 5 times the square root of 3 equals 5 radical 3. So our long leg is 5 radical 3. That's a little quicker than doing the Pythagorean theorem, I think. Let's do one more. These are fun. These are fun. Here's our 30. Here's our 60. And we got a 21 right here. X and Y. So our X, which side of the triangle is that? It's the hypotenuse. So what's X equal to here? Short leg times 2. Hypotenuse equals short leg times 2. Hypotenuse equals 21 times 2. Pretty sure that's what? 42, good. What's the long leg equal? What? 21 radical 3, very good. Because the long leg equals the short leg times the square root of 3. So we got 21 radical 3. We're done, right? Nothing to simplify. No perfect squares under the radical. We're good to go. Anybody got any questions about special right triangles? All right. Your practice for today is going to be on page, you're going to do, ooh, come on, page 101, 1 through 16, and then page 102. That's 1 through 14. And then I want you to check focus for homework. All right, and we're going to work on this until it's completely finished or until the bell rings. Maybe put your phones away for a little bit. Wow, you guys are so addicted to those things. I don't know if you can. Poor children.